All right, for section 3.4.5, we want to talk about solving quadratic equations with perfect squares. So again, before we get into the complicated equations, I want to look at something simple. So here's a quadratic equation. It's got a squared. X squared equals 36. You've seen this before. How do you undo squaring? Take the square root. So if we want to get x by itself and we take the square root of each side, that'll give us x equals, and keep in mind 6, or x could be negative 6, because 6 times 6 is 36, and negative 6 times negative 6 is 36. All right, same thing over here. X squared equals 5. To solve that, take the square root of each side. What happens when that doesn't work out? What's the square root of 5? We just leave it as x equals the square root of 5, or x could equal negative the square root of 5. All right, so that's looking at the simple quadratic equations. Now let's look at something a little more complicated. What if we have something like this? X minus 5, the quantity squared, equals 7. If you have the squared term isolated, again, you can, to undo this, just take the square root of each side. So you get x minus 5 equals the square root of 7, or x minus 5 equals negative the square root of 7. Okay, well, we don't have it solved for x. We need to undo what was done to the x. So since 5 was subtracted, as long as we do the same thing to both sides, x is equal to then the square root of 7 plus 5. Or if I add 5 here, x is equal to negative the square root of 7 plus 5. So here's my solution to this quadratic equation. X equals the square root of 7 plus 5, or x equals negative the square root of 7 plus 5. Let's go to the next step. All right, what if we have something like this? Same thing, it's a binomial, squared equals 10, but again, you take the square root of each side to get rid of the squared term. That gives you 2x plus 3 equals the square root of 10, or remember, there's always two possibilities. 2x plus 3 equals negative the square root of 10. Okay, again, you're solving for x, it's just there's an extra step in this. If you're solving for x here, to undo this, you'd have to subtract 3. So you get 2x equals the square root of 10 minus 3, and then you have to undo the 2 times x. So to undo 2 times x, you need to divide both sides by 2. So x is equal to the square root of 10 minus 3 over 2 for one of your solutions. And the other one, we better do this over here. Subtract 3. So 2x equals negative the square root of 10 minus 3. Divide by 2. So x equals negative the square root of 10 minus 3 all over 2. I know it looks kind of complicated, but actually it's not much different than the first ones I showed you here, where basically all you do is take the square root. To undo a square, take the square root of each side. All right, now you're going to run into some problems where it looks just like this, and you're in this section solving with squares. If you can write it, a quadratic equation, as a perfect square, that can help you solve it. And if you remember what we learned from the last unit on 3.3, perfect square trinomials, you've got a perfect square here, you've got a perfect square here, and 3x doubled is your 6x. So this is a perfect square trinomial. This is x minus 3 squared equals 11. So you're going to have some problems where you're going to have to maybe look at it and recognize that's a perfect square trinomial, write it as a perfect square. If you can do that, then you can do that process of just taking the square root of each side. So x minus 3 equals the square root of 11, or x minus 3 equals negative the square root of 11. One last step, add that 3 to both sides. So x equals the square root of 11 plus 3, or x equals negative the square root of 11 plus 3. All right, so you're going to run into some examples where you might need to factor it yourself. Here's another one. Looks kind of crazy, but if you look at it, this is a perfect square here, 2x times 2x. 9's a perfect square. 6x doubled is the 12x. So that is a perfect square trinomial. So we can write that as 2x minus 3 squared equals 5. And then finish it from there by taking the square root of each side. Square root, square root. So 2x minus 3 equals the square root of 5. Or 2x minus 3 equals negative the square root of 5. Couple steps on this one. Oops, add 3. So 2x equals the square root of 5 plus 3. One more step of dividing by 2. Okay, and then on the other side, x is going to equal negative the square root of 5 plus 3 over 2. Okay, before I send you off to take the quiz on Apex, I want to go over one more thing because they're going to simplify some of these problems. We haven't talked too much about simplifying radicals, but let's say you have the square root of 8. Radicals can sometimes be simplified, okay? Now, if you think of 8, if you write out the prime factors, 8 is 4 times 2, and 4 is 2 times 2. So the factors of 8, we can rewrite 8 as 2 times 2 times 2. Well, if you look at this, you've got 2 2's, that's 2 squared. You've got a perfect square there. So if you have 2 squared, the square root of 2 squared is just 2. So every time you have a pair of numbers inside the radical, you can take it out. So to simplify the square root of 8, we can rewrite it as 2 radical 2. Let me give you another example. Let's say the square root of 12. Okay, we're looking for a perfect square that goes into 12. Now maybe you can think of it, well, you know what, Kim, 12 is 4 times 3. And I know that 4 is a perfect square. The square root of 4 is 2. So I can just write that as 2 square roots of 3. Okay. Or again, if you would have written 12 and done your little factor tree like you learned in grade school, 12 is 4 times 3, 4 is 2 times 2. Okay, you can write 12 as 2 times 2 times 3. And again, you've got a pair of 2's here, so you can take those out. That's 2 square roots of 3. Just 2 different ways to look at simplifying. I brought that up because on the quiz, some of your answers, when you do some of these problems like this, you might have something here that can be simplified. Like say this, maybe it can be simplified more. And so when you look at your answer and what they have, it might look a little different. Just check to see if maybe they simplified it. All right, so if this makes sense to you and you understand it, you can go ahead and take quiz 3.4.5. If you'd like to do some more practice problems, you can come see me and I'd be happy to get those for you.